So here we have the last part of lesson 3.4. It's problem situation 2. Problem situation 1 was the weight loss program. Now we're going to compare milk consumption in the US to soda consumption. So let's just take a quick read through this and then try and summarize it. When I'm solving a problem like this, I usually have to read it a few times to wrap my mind around it. So feel free to pause me if you're in the future. Since 1950, the US per person consumption of milk and soft drinks has changed drastically. For example, in 1950, the number of gallons of milk consumed per person was 36.4 gallons. So that's in 1950, the average person consumed 36.4 gallons of milk per year. In 2000, the number had decreased to only 22 gallons per person per year. Meanwhile, the number of gallons of soft drinks consumed per person in 1950 was 10.8 gallons, much lower than the milk people were consuming per person back then. But in the year 2000, it jumped up to increase to 49.3 gallons per person. Whoa, per year. It's a lot of soft drinks. All right, so we have to keep track of the year, the milk consumed, and the soft drinks consumed. So I'm going to make a table that does that. So I need the year. I need to keep track of milk consumption. I'm just going to call it milk. And I'm going to keep track of soft drinks. Drinks has a K, not a G. And both the milk and the soft drinks are gallons per person per year. Right, so that's these two, how they're measured. So in 1950, milk was 36.4. And then in 2000, milk was 22.6. So we can see there's a definite drop there. Soft drinks, let's do that a different color. 1950, soft drinks were 10.8. Oops. 10.8, that's better. And in 2000, it increased to 49.3. So what I've done here is, for example, for milk, I have a point, 1950, 36.4, and then another point, 2000, the year, and 22.6. And so I'm asked to graph that point. And similarly for soft drinks, I have a point, and the point would be 1950 goes with 10.8, and 2000 goes with 49.3. Right, so I have two sets of points. So I'll write those out separate just for fun. For milk, and let me look at that graph that they gave me to play with. The horizontal axis is years after 1950. Oh, okay. So they're doing something a little bit different there. So 50 would be 1950 plus 50. So that would be the year 2000. So the year 2000 would be 50 years later. Where's 1950? Well, I guess that would be 0 years after 1950, would be 1950. Okay, good to know. So if I were to try and graph the first one for milk, in 1950, milk was 36.4. So 1950, let's see, that's 30, that's 40, 35 is in the middle, 36.4 is just gonna be a little higher, maybe right around there. And then in 50 years later, in 2000, it is what, 22.6. So there's 20, 30, 25 is in the middle. 22.5 would be in between, 22.6, somewhere here-ish. And if you're not sure if you got the points in the right spot, like here, I missed the axis a little, I can just pick it up and move it anywhere I want. So this one is supposed to be 36.4, I'm guessing is about there-ish. Hard time placing that. Close enough. And this one, I think that one looks reasonably well. My mouse keeps lifting it up after I let go. It's in the vicinity. Now don't submit till you graph the other one. So I got to do the other one too. If I click another point, it's going to bring up a new line. So often when I'm doing this, it takes me a couple tries to get one I like, and sometimes I have to clear and start over. So let's see, soda, soft drinks, 10.8 in 1950. 10.8 is around 11. 11 is going to be around here-ish. And then the other point in 2000, 50 years later, 49.3. Ooh, I accidentally put it in the wrong spot, but I can pick it up and move it. 49.3. That's pretty darn close to 50. So somewhere up here-ish. So I think I got those in the right spot. It's always a good idea to double check. So let's see, up here, 1950, milk was 36.4 and 35, 36, that looks a touch high. I'm gonna move it down a bit, maybe there. Looks better. And sometimes these are picky about your points, sometimes they're not. And then in 2000, 22.6. So that's 20, that's 30, that's my best guess at 22.6. I like it, that's good. 1950, 10.8. So 1950 is where we start on the axis. And that's pretty close. And 2000, 49, just under 50. Yeah, I think I'm good there. See what it thinks. Ooh, I did good that time. Okay, so my recollection is this one is a little lenient, but if your point's way off, it's not going to go well. So for example, oh, I don't want to submit it again. I want to clear it. If you said the first point was like way down here, that's not quite right, but it might take that. And the other one, maybe I guess here. So if I'm not careful enough about this, and I submit, ooh, it still liked it. Okay, this one's got plenty of wiggle room. So just make sure you graph 50 years later and at year 0, which is 1950. All right, and then look at the graph and guess what year they meet in. Now, looking at my graph, it looks like X is around 25, but I can't say they meet in the year 25, right? What does that mean, the year 25? That was a long time ago. It's the year 2020 now, and they're talking about 1950. Super important here, and this is something I would write on my paper, which I need to do in a moment. The horizontal axis is measured in years after 1950. So if I see something like 20 here, that's really 1950 plus 20 or 1970. If I see 25, that's 25 years later, so that would be 1975. If I see a 40 here, that's 40 years later or 1990. So super important. That's something that's worthy of putting on your notebook paper for this problem. That my horizontal variable I'm being invaded by teenagers here. Wish me luck, guys. Teenagers home for lunch, I hope, and not skipping class. Now they made me lose my train of thought. Horizontal variable, I don't know if we're going to call it X, maybe we'll call it T, is years after 1950. So I'm going to add a new column over here for, let's call it T. So 1950 would be 0 years after 1950. 2000 would be 50 years after 1950. And then if I put something like 25 years, that would be 1950 plus 25 or 1975. And I could look at the graph and guess what those numbers are. And on my graph, they look to be about the same, right? About what? They're around 30 gallons-ish. Your graph may look a little different depending on how you plotted your points. So I'm guessing, question mark, that they were around 30 there. Okay, equations. What would those look like? For the equations here, all right, we've got many variables. We have an M for milk, pretty good. I'll buy that. An S for soft drinks, okay, or here they're calling it soda. and a T for the years since 1950. So I have some of that in my notebook. So let's see, I wrote down the T here, and then milk here, we're just going to call that M, put that in parentheses, and soft drinks or soda, we're just going to call that S. So for example, my milk equation, what's that going to look like? Well, for the milk equation, I would have to find the slope. Slope, remember, is the rise over the run. So I have to figure out, well, what's that rise there? Now here it's a drop. So to show that drop, I would write 22.6, the future amount, minus the past amount, 36.4. 22.6 goes with the 50, so the 50 has to go under it, minus 0. Check that on a calculator. I have another video where I do this on a spreadsheet. So 22.6 minus, what was the other, 36.4. Yep. So that's my numerator, negative 13.8. And then we're going to divide that by 50. I'm just going to take that number, divide by 50. And so my slope there is negative 2.76. So my numerator here was negative 13.8. I still have to divide by 50. Once I did that on the calculator, I'm getting the slope for milk was negative 0.276. So then the equation has to be, remember equations always look like y equals mx plus b. Y, they said to use an m. My m is negative 0.276, oops, 276. They said use t instead of an x, and the starting value is that 1950 amount, which would be the 36.4. So I want you to do a similar thing for the soft drinks. Calculate the change in soft drink consumption. You can see that one's going up. It should have a positive slope, whereas the milk had a negative slope. Figure out what that is and figure out what your equation is. S equals blank times T plus blank. So fill in the blanks there. I'm gonna pause my thing for a minute here. So for the soft drink soda in the future, after 1950, it was 49.3. In the past, it was 10.8. So we always do future minus past. So that's the order of the subtraction there. And 50 years went by. So I can just take that previous answer, divide it by 50. Now I could have done that in one calculation. Sometimes I don't really care what the rise is. I just want to know what the slope is. So if I wanted to do it in one shot, I would either set up my division first or my fraction first. Either one works here. And then in the top, I would type my 49.3 minus the 10.8. And in the bottom, I might just type 50, or I might be extra cautious and type 50 minus 0. So here's me typing the rise in the top and the run in the top. And I think this second method of doing it is better, because often what I'm going to do is I'm going to calculate this number here, and I'm going to write it down on paper. Then I'm going to type it in again and do another calculation. And I'm introducing the chance for errors in a couple of ways. One is rounding error. The one is miswriting or mistyping it. So here I just put all the information in at once and I just get a slope out. So I think this last way is really the best way to use your calculator for a slope. Set up the fraction first and then do your subtractions. Now you may have a different kind of calculator, and most calculators that come with your smartphone, most of them kind of suck. So I would recommend, like on my phone, I've downloaded the Desmos Scientific Calculator app. It works way better than my iPhone calculator. Is a piece of crap. I like the iPhone in general, but the calculator sucks. If you have an Android type calculator, it's going to look more like this when you turn your calculator sideways. And this one requires careful use of parentheses. So on this calculator, I would have to type the parentheses 49.3, then minus the 10.8. Close the parentheses for the numerator, divide to form the fraction, and parentheses to form the denominator. So notice I have parentheses around the numerator, the rise, parentheses around the denominator, the run, And the division symbol is the same thing. A fraction bar is division. And so I should get the same number I got before. And that is the way you would have to type it if you're using a spreadsheet for this also. So for soft drinks, my equation would be 0.77 T plus the starting amount, which was the 10.8. So those are my two equations that I have to work with. And then the last step for this problem is to actually calculate instead of guess when are they the same. So let's do that. When does milk consumption equal soft drink consumption? And to solve that, I just write down my milk expression, write down the soft drink expression. So by expression, I mean the milk was negative 0.276 T plus 30, what was it? 38.4? 36.4. And I want to know when does that equal the 0.77 T plus 10.8. So we'll set about solving this. Double check I typed it right. I think that looks good. So to solve an equation like this, first thing I do is I look at, well, can I simplify the left side? Because of the T here, the answer is no. Can I simplify the right? Because of the T here, the answer is no. So the only thing I can do next is start moving things side to side. And I tend to like my variables to move to the left and the other numbers to move to the right. So for example, I would subtract the 0.77 T. And for any complex problem, there's going to be many possible ways to do it and get the right answer. Now here, my goal was, since this is a positive number that's added, I'm subtracting it to get rid of it from that side. So that should add up to a 0, leaving just that 10.8 on the other side. On the left, I haven't messed with the 36.4, and I got to calculate what that subtraction is. I can kind of look at it and guess here. 6 and 0 is 6. The T is hanging out. 7 and 7 is 14, carry the 1, 7, 8, 9, 10, 0, carry the 1. So I think I get negative 1.46. That was a messy negative, 1.046. And again, this matters. I want to double check that I got that right. Negative 0.276 minus 0.77 is negative 1.046. I got it right. All right, so I've cleaned it up a little bit. Since I took the T from right to left, I'm going to take the 36.4 from left to right. So now I'm going to subtract the 36.4 over. And the point is that should add up to 0. It's gone. So now I have just negative 1.046. Missed that 6. There we go. T equals whatever that subtraction is. We're going to check that on a calculator. So let's see, it was 10.8 minus 36.4. Have that right? 10.8 minus 36.4, yep. So that's negative 25.6. Oops, wrong page, right page. Negative 25.6. And the second to last step here is to get rid of that multiplication by dividing by that number out front. Good sign, a negative divided by a negative is a positive. I'm certainly hoping for a positive answer here. So what does that yield? So take that previous answer, which I can use the answer button, that'll tell me what the previous number was, divided by negative 1.046. Did I type that right? Yep. So it looks like 24.474, 24.5, maybe I'll round that to. So to indicate I'm rounding, wavy equal sign, 24.5. T, remember, is years after 1950. Very important. So let's see, if we add on to that, that would be 1974.5. And earlier I made a guess looking at my graph of 1975. Hey, that's close enough. I think we did pretty good there. Woohoo. And I think we just kicked this activity in the pants. Got a graph. We made an estimate. Hopefully you wrote yours in. We came up with equations here and here. And then we did a little algebra for T, and then for the actual year. All right, nice work. So I'm gonna pause here, let you guys catch up if you need to before we move on.